Now we classify the fluids we have into two parts. One we call as ideal fluid and second one are the real fluids. So in our universe, there is no ideal fluid is available, but to study the theoretical part of fluid mechanics or fluid machines, we have to consider the concept of ideal fluid. Now the meaning of ideal fluid is fluid which do not deform when, sorry, you can define the ideal fluid as the fluid which is incompressible and non-viscous. Means ideal fluid is that one which have no viscosity and which is incompressible. So that we call as ideal fluid. Now in real fluid, we have different categories. First category we call as Newtonian fluids. The second category is of non-Newtonian fluids, and third category is of ideal plastics. Okay. Now real fluids you can call, these are the fluids which have some compressibility and viscosity. So in all these three types, we have some compressibility as well as some viscosity. So now we take these fluids one by one. Now the Newtonian fluid we call as the fluids which obeys Newton's law of viscosity. Now this law is tau is equal to mu du by dy. Now here the tau is shear stress, mu is viscosity of fluid, the term du is change in velocity, and term dy is the distance between two successive layers. Now we discuss this law in detail when we discuss the various properties of fluids. So here you just know this is our Newton law of viscosity. So fluids which obeys this law we call as Newtonian fluids. The example for Newtonian fluids we have air, the another one is water, then another one is kerosene. Okay. Now the fluids which do not obeys Newton's law of viscosity that we call as non-Newtonian fluids. So here tau is not equal to mu du by dy. But there is some relation between tau, mu, du and dy. So that relation we can write as tau equal to k times du by dy raised to power n. So here k we call as consistency index and n we call as flow behavior index. Okay, so n is the flow behavior index and k is consistency index. So depending upon the value of n, we have now two different types of non-Newtonian fluids. The first type of non-Newtonian fluids that we call as sorry that we call as uh, pseudoplastics. The second category we call as dilatant. So pseudoplastics and the dilatants. These are the two categories of non-Newtonian fluids. The difference is for pseudoplastics n is less than 1 and for dilatants n is greater than 1. So you can say for pseudoplastics fluids which has flow behavior index n less than unity are called pseudoplastics. The example for pseudoplastics fluids are milk and then blood. Okay, and for dilatant you can say the fluids which has flow behavior index n greater than unity, and the examples for this type of fluid we have printing ink. The another example is concentrated sugar solution. Concentrated sugar solution. The another example of dilatant fluid is aqueous suspension of a rice starch. Okay, so printing ink, concentrated sugar solution, and aqueous suspension of rice starch. These are some examples of dilatant fluid. Now, the third type of fluid for real one we have the ideal plastics. So, the ideal plastics are those fluids which do not deform when stressed up to certain limit. So, do not deform when stressed up to certain limit. Okay, and beyond that they behave like a Newtonian fluids. So such type of fluids we call as ideal plastics. The examples for such fluids we have the sewerage sludge, the one example. The another one is water suspension of clay and fly ash. So sewerage sludge, the one example. The another one is water suspension of clay and fly ash. So that are the examples of ideal plastics. So these are the different types of fluids we have. Now, if we try to draw a graph or a plot, that plot is between tau along y-axis, that is the shear stress, and du divided by dy, that is along x-axis. So for Newtonian fluids, tau is directly proportional to du by dy. So there is a straight relationship for Newtonian fluids. So for ideal fluids, there is no viscosity. So you can say along x-axis we have the ideal fluids. For ideal plastics, you can say there is no deformation up to certain point, and beyond that the fluids behave like a Newtonian one. So this is ideal plastic. Okay. Now for pseudoplastics, n is less than 1. So curve is something like this. And for dilatants, the curve is like this. So this is dilatant. So this is how you can represent different types of fluids along tau and du by dy curve. So these are the different types of fluids we have. So next we discuss the different types of fluid properties. So that we discuss in next part of the lecture. Okay, thank you.